Hello, future engineers, subscribers, viewers, and students. Here is the solution to, to the equilibrium problems in statics, squeeze problems. So this is the first, a prismatic bar AB of weight Q and length L is the length of this prismatic bar. Uh, this is the AB. A weight Q, so acting at the center of this bar AB, and length L, so that's why we have L over 2, L over 2, rests at A against a smooth horizontal floor, and under the action of its gravity force, Q presses against supports C and D. Neglecting friction, determine the magnitudes of the reactions at A, C, and D in terms of the given parameters. So first, let's draw the free body diagram of this prismatic bar. And since the floor is smooth, the contact surfaces are smooth, then the normal reactions or reaction should be perpendicular to the contact surface. So for instance, at the bottom, since the contact surface is horizontal, the reaction should be vertical, perpendicular to the horizontal surface. So I'll call the reaction as A. Then at C and D perpendicular to the axis of the bars, the contact surfaces are smooth, so we have C and D. So this is the FBD. Original angle here is theta. So this is the line perpendicular to the axis of the prismatic bar, and which I call x prime in that direction. So therefore, the angle that the bar makes with the angle between the vertical and the axis perpendicular to that bar is also theta. So we have theta, that's theta. So this is also theta, just like that. Summation forces along y prime axis equals 0. The component of A in that direction, upward direction. Since this is also theta, the component of A is this, opposite of theta. So that is A sine theta, this component. A sine theta equals the component of Q is in the negative direction, which is this direction, parallel to the axis of the bar. So that is Q sine of theta. So cancel out sine theta, so we conclude that A equals Q. So A is Q, that is Q. So it is a couple, clockwise couple. Likewise, summation forces along the x prime axis equals 0. Then we have D in the positive direction plus the component of Q in that direction, which is Q, this component, Q cosine theta, then minus C, which is that, then minus the component of A in the positive x prime direction, but it is in the negative x prime direction. That component is equal to this, and it is adjacent to theta, so A cosine theta. So D minus C plus the component of Q in that direction, which is Q cosine theta, minus the component of A in the opposite direction, in that direction, adjacent to theta. So that is minus A cosine theta equals 0. But A is equal to Q, so these last two terms will vanish. So leaving D equals C as our conclusion. Because C is equal to D, then the moment between C and D is a couple, which is counterclockwise. Then summation forces or summation of moment equals 0. Counterclockwise couple is C times A, that's counterclockwise, or D times A, is equal to clockwise couple. So we have Q and Q, so it is a clockwise couple. The distance or moment arm between them is L over 2 cosine theta, because from Q to this bottom here, that's L over 2 then times cosine theta. So that is CA equals Q times L over 2 cosine theta. Again, this is uh, counterclockwise couple equals clockwise couple. Simplifying, C equals D equals QL cosine theta over 2A. And A is equal to Q. So that's it for this part of the video. So for this second problem, a prismatic bar AB of length 1.5 meters, weighing 20 newtons, supports the circular cylinder shown of radius 30 cm. So the radius of the cylinder is 30 cm and weight 240 newtons. The vertical wall is perfectly smooth. So here, of, co of course, on the contact surface also. And the other end of the bar is tied to a horizontal cord BC. Determine the tension in the cord, tension here. What should be the length of bar AB so that the tension in the cord will be a maximum. So requirements here would be the tension in the cord and the length of bar AB so that the tension in the cord will be a maximum. So for the tension in the cord to be maximum, the moment arm of the tension force about A should also be minimum. So that is the analysis is this cord will just be tangent at the top. And that is the greatest moment arm so far without touching the cylinder. That is this vertical distance to A because we will sum up moments about A to solve for that tension. So if we draw the free body diagram of this cylindrical body, so the weight is 240, then we expect normal reaction there perpendicular to the vertical and normal reaction at this point perpendicular to the inclined bar. So if this is 50 degrees, this angle remaining is 40, and since from A to the center of the cylinder, that is the common hypotenuse of two right triangles, that triangle at the left and this right triangle here. Take note, the opposite to 20 is radius, and the hypotenuse is common from A to center of the cylinder. That's why here also, that's 20 degrees, this is 0.3, so that distance is also equal to that distance there. So to solve for that distance, tangent of 20 is 0.3 meter over this distance here. So therefore this distance is 0.3 over tangent 20, and that is 0.8242. The distance from A to this point here of tangency is also the same as 0.8242. So it is shown here. So summation, summation, just focus on the cylindrical object first. Summation versus vertical to solve for NE. So the vertical component of NE is NE cosine 50 degrees. NE cosine of 50 degrees then equals to 40. So that's why N sub E is 373.37 newtons. Then summation forces X equals 0. ND equals the horizontal component of NE, which is 373.37, then sine of 50. ND therefore is 286.02 newtons. So that's the distance of ND from A, which is the same distance of NE from A. So if we just consider the free body diagram of this part, so we have tension, then ND, AX, AY, weight of the bar 20. And since the distance from A to that point is half the length of AB because it is prismatic, the bar is prismatic. So from A to the point of application of this 20 Newton force, that should be equal to half of AB, which is 0.75. And since it is inclined, the horizontal projection is 0.75 cosine of 50 degrees. So summation of moments about A, consider this FBB. Counterclockwise moment equals clockwise moments. Counterclockwise moment is T times 1.5 sine 50 degrees, then equals NE. Let's have ND, the weight, and the weight of the bar. We are not touching this point, so we don't reveal NE. In our alternate solution, we'll have that after the explanation of this. So again, counterclockwise moment, T times 1.5 sine 50 degrees equals clockwise moments. So beginning with ND, 286.02, and that is 0.8242 already explained as 0.2 divided by tangent of 20 degrees. Then plus 240 times radius, 0.3. Then plus 20 Newton weight of prismatic bar. Moment arm is 0.75 cosine of 50 degrees. Solving for tension to 76.2 newtons. Then for another way, so this is the FDD of the bar. Another way, let's transmit the normal reaction 373.37 at E, and that distance is the same as 0.8242. I already explained that. So we have 20 newtons, same distance, 0.75 cosine 50 degrees from A, and of course the tension, same distance, 1.5 sine of 50 degrees. So summation of moments about A equals 0. We have counterclockwise moment equals clockwise moments. So for the clockwise moments, we just consider this two forces here. So the normal 372.37, moment arm 0.8242 plus 20 times 0.75 cosine 50 degrees. So using your calculator, the tension is 276.2 newtons. And for the minimum, the length of AB, so that the tension in the cord will be a maximum, the tension in the cord is maximum if its distance from a perpendicular distance is the smallest, so that T times smallest distance equals moment, then T is moment over smallest distance, and that would be maximum. So that's the idea, and for that to be maximum, it will just be tangent to the top surface of the cylinder. It touches gently. So since this is already 0.8242, and that's the radius, that vertical component is equated into LAB, the new length of the prismatic bar, sine of 50 degrees. So LAB sine 50 degrees is 0.8242 plus 0.3. So the length of AB should be 1.468 meters to maximize the tension in the cord BC. So that's it for this video.